Hello! My team will present a digital clock by using Acheda today. Before I start, I will introduce my team first. Firstly is Khalid. Secondly is Takif. And lastly, it will be me. Since ages, clock is useful for humans looking for their time. At this time, most people in the whole world use an automated digital clock in their everyday use. Starting from the hand watch, we were to those use strict clocks. Every one of us are dependent on the display they make. In 21st century, time being more than money. Regarding discharge, our hobbies of checking our time every minute is dramatically increased. About 99% of today digital clocks are made using microcontroller, which makes them more handable from the rest. Thus we can set the time to start any minute or second we want, and also set an alarm for reminders so that the system will store the value in a memory, and then when the time reach, the alarm will be on. As the microcontroller consists almost all the logical device, external logic gates doesn't exist. In order to be used properly and for a long life usage, digital clocks must cover a very small place as much as it could, but the size of most of digital clocks manufactured this time unexpectedly increasing as the gift increase. These are the list of problems that exist today. An extensive range of large use of dependent LED matrix digital wall for the display that takes a huge space in the circuit, and lot matrix code in the controller display only hour and minute. This make the use they give us limited on the range given. Our objective is to propose system will be using a JK flip-flop to make the synchronous counter that counts the hour, minute and second, and also use 3 push buttons to set those outputs. Next, Khalid and Takif will present about the clock in Cheddar. Check it out.
Assalamualaikum, my name is Muhammad Khalid bin Walid, matric number 20106312 from Mechatronic course, and my group mini project are digital clock. There are two main components of the digital clock, which is a counter and decoder. For the counter part, I will explain shortly. As you can see from the most left, we have the second counter that will count 0 until 9, which considered as a decade counter, as it count to the for 10th time. When the counter reach the count of the 10th time, which is the number 9, and the clock gate will detect the number 9 being output by the counter. It will act as the clock for the another seconds counter, act as a mode 6 counter. When the first second counter reach 10 seconds or 10th count, the another second counter will clock one time pulse until it reach 60 seconds. The process repeats. On the part of the clock, the second clock will detect the 6th count, which is value 5 of the counter output, and the clock time pulse determine that is 60 minutes, which mean 1 hour for a counter. The hour counter will count from 0 until 11, as it is mode 12 counter, and the clock will be reset again when reach 12th count. The combined circuit are the consist of a JK flip-flop, and the clock gate are the gate that make sure every counter clock and precise count in order to create a synchronous digital clock. For the decoder part, my friend Takif will explain later. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Takif bin Ashimi. My matric number 20106135. I want to talk about construct the decoder 7 statement. So this is a logic gate for minute and second to display 0 to 6. So I use 4 input because in counter we use 4 JK flip-flop. So you can see this is a input. First step you must do two table first. You must construct two table first, and then you put data into the KMap, and then you can get a Boolean expression to do the logic gate. So this is a example when input 0 0 0 0. So then this decoder can display a 0 when input 0 0 0 1. So then this can display 1. This is another decoder. This is our decoder to display 0 to 5. So this decoder we use 3 input only because for the counter we use 3 JK flip-flop. So this is example input that I put 1 0 1, so they can display 5. So and then this is logic gate for our decoder. For our decoder we use 2 decoder in one counter because we cannot display 10, 11 and 12 in one decoder. So we construct 2 decoder to put in one counter. So this is example input when I put input 1 0 1 1, you can display 2 mean 12. Same this for and this, same for this input when I display 1 0 1 1, they can display 1 for 1 and 2, so that means it can be 12. So thank you for me. Bye bye.
This is combinational circuit of the counter and decoder to make a digital clock. I will show you the picture. Our conclusion is we have completed this project successfully and have successfully made a 12-hour digital clock. Bye.